All right, I think we are ready to start. Good evening, everyone. And Suzanne, just a quick check if everything is recording and everything is live. I'm saying this, but I just want to remind all our attendees that this event is being recorded. So again, good evening and welcome to our third presentation in the series on the James Webb Space Telescope that is offered to you by the Christa McCullough Center for Integrated Science Learning. My name is Irene Porro. I am a director of the Christa McCullough Center. And again, for the third time in a row now, I'm so delighted to be your host tonight. So a little bit of housekeeping if you want to get started as usual. I want to remind all of you that our in-person monthly public planetarium shows will resume this coming Friday, September 15th. So for information about this event and the calendar of both in-person and virtual events, you may want to check our website. And I did put the link already in the chat box. Let's see if I can hit it again. I'll do it right now, right there. This is a link that we will share with you a few more times tonight. That's where you want to go for any information related to the planetarium presentation and our astronomy presentations on virtual presentations. Just to make it clear, in-person virtual presentations do not overlap. They're going to be a little bit different. Explorations of the night sky will be done in a physical planetarium. That is where they should be done. But virtual presentation will focus on the specific topics in space science and astrophysics, just like we're doing tonight. Now, you are most welcome to attend both our in-person and virtual programs, of course, but we understand also that it's good to give you an option so that you can choose a medium that you prefer to keep engaging with our team of great presenters. So for tonight, as I mentioned, we continue our introduction to the James Webb Space Telescope mission. And I know I said this before, but I need to repeat it again every single time. Webb will be the largest, the most powerful and complex space telescope ever built and ever launched into space. Now, we're all excited about the mission, but now we're really getting close to being to the launch, and the excitement is growing. Now, this launch is being rescheduled. We just learned this week that now it's planned for December 18th, 2021. Keep that date in mind, because if it's confirmed, we will do something special at the McCullough Center to celebrate this launch. Now, just as a reminder for all of us, maybe some of you are joining us for the first time. So Webb was specifically designed to see the first galaxies that are, as they are forming, just shortly after the Big Bang. However, its infrared sensitivity and its unprecedented resolution in the infrared makes it the perfect instrument to explore the regions where stars and planets are formed, to trace how galaxies have evolved over time, and to study the atmospheres of exoplanets. These are the planets that orbit other stars, stars other than the sun. So Webb is potentially so transformative for astronomy that 3 international space agencies, NASA, the European Space Agency, and the Canadian Space Agency, have actually partnered and came together to bring it to launch. In our earlier presentations, we were introduced to the mission and the engineering aspect of these incredible telescopes. And in fact, you can check our website again and find a recording of these presentations, or also simply just go to our YouTube channel. Tonight, we will introduce you a bit to the revolutionary research that we are expecting to be able to do thanks to the data that Webb Space Telescope will provide to us. Now, just to be clear, tonight we have a great speaker, but he will just be able to give us a little bit, a general overview about all the great science that Webb will be able to do. However, if you're intrigued by this unprecedented science that Webb will make possible, you do not want to miss our special event in October 15th, that we will host at the FSU Planetarium with Dr. Kathy Flanagan, one of the researchers that has been working on Webb for many years as a keynote speaker. Just in case, if you wonder, yes, the event will also be live streamed. Again, for specific information, go to the website that I just posted earlier in the chat. All right, and now I think everybody that wanted to join us may have done it, so we can get started with our presentation. Oh, I don't want to forget to remind you all that, as usual, in order to ask questions to our speaker, we will use a Q&A box that is located in the bottom right of your Zoom window. Also, please keep the questions for the end, where we will be happy to address all of them. And it's now time to introduce our speaker, that once again is John Shepp. He already gave us the first two presentations, and now is ready for this third and closing one for this series. As you know, John is a program facilitator here at the Christa McAuliffe Center, but he is also a NASA JPL Solar System Ambassador, and he's a member of the Amateur Telescope Makers of Boston, among many, many other things that he does. But without further ado, I want to welcome John back and leave him the screen and the mic.
Thank you, Irene, for that wonderful introduction. I hope everybody can see the shared screen and can hear me okay. So as Irene said, later this year, NASA and the European Space Agency will launch the James Webb Space Telescope. It's going to be the largest, most complex telescope to ever launch into space. And again, as Irene said, for those of you who might be joining us for the first time, this is the third of 3 AstroNights devoted to talking about the James Webb Space Telescope. The title slide says the James Webb Space Telescope, a giant leap forward in our quest to understand the universe and our origins. A short translation of that last phrase might be, what are some of the things James Webb may reveal to us? So that's what we're going to be trying to talk about tonight, and we'll see what we can learn. But I'll tell you right now, I'm very excited about this mission. So let's review the science objectives of the James Webb. Number 1, studying the first stars and first galaxies in the early universe. Number 2, studying the formation and evolution of galaxies. 3, studying the birth of stars and protoplanetary systems. And 4, characterizing other worlds. Now, the James Webb was originally built for the purpose of just these first 2 objectives, studying the first stars and galaxies and studying their evolution. But when we realize that we will have this marvelous, capable instrument up in space with its characteristics, we realized it could do a lot more than that. It could study stars and star birth, and it could characterize other worlds, exoplanets, planets that revolve around other stars, and as well as planets in our own solar system. So what gives James Webb the ability to meet these objectives? Well, 2 things. First of all, a very large mirror. This is what James Webb will use to capture light coming in from distant objects. And because of the size of the mirror, it can catch more photons, more light. Therefore, it can see fainter objects. That's number one. The number two advantage of having a big mirror is that it increases your angular resolution. So you can see greater detail when you focus in on an object. And finally, the other main advantage of this telescope is that it's an infrared telescope. So if you look at this diagram of the electromagnetic spectrum, the James Webb telescope will see objects in the infrared. So that ranges from the near infrared to the mid infrared. And it's a region that has been largely unexplored with spacecraft this capable. So we expect discoveries and surprises. The Hubble telescope, by the way, could only see visible light from violet to red and a tiny bit into the ultraviolet and a tiny bit into the infrared. And the Spitzer Space Telescope could see into the far infrared. I believe that's no longer working. It's past its lifetime. But the James Webb is what we're excited about and what we're going to focus on. So let's look at those science objectives again. Number one, studying the first stars and first galaxies in the early universe. Okay, this is a picture that I'm going to enlarge in the next slide. This is known as the Hubble Ultra Deep Field. And the Hubble telescope was pointed at a certain region of space that looked empty. And it captured this image over a course of 25 days. And this is what we found. It's hardly empty. What you can see here are a couple of stars that have diffraction spikes, like that one and that one. But everything else you see, every little dot is another galaxy, potentially with hundreds of billions of stars. Some of the nearer ones you can make out detail on, like this beautiful little spiral here and this spiral here. But every single one of these dots, even the smallest ones in the background, there are about 10,000 of them, by the way, all of them are galaxies. And some of the fainter ones are likely to be 13 billion years old and have formed just less than 1 billion years after the Big Bang itself that created the universe. So, but we can't really go further than this. Scientists know that there are galaxies beyond this that current technology is unable to resolve. But the James Webb will be able to do that. It will provide us a window into the more distant past, into younger and younger galaxies. Let's look at this. This is a timeline starting with the Big Bang, and this is the present day here. So the Hubble deep field that we just looked at goes maybe about this deep into the past of the universe. The James Webb Space Telescope will be able to see all the way to the end of the Dark Ages. And that's exactly when the first galaxies will have been forming and the first stars will have been forming. So we can't see this with present technology, but the Webb telescope will let us do that. Here's a comparison. These two images on top are from the Hubble Ultra Deep Field. It's a portion of the field, and this is a portion of the portion that's been blown up. And what you see here, you can barely make out that it's a galaxy, possibly with spiral arms, but it's very hard to see any detail. These bottom two images are simulated views of what the James Webb Space Telescope will see. And again, this same patch of sky is blown up, and here you can see a lot more detail in this galaxy, including spiral arms and even individual stars and globular clusters. What's more, in the background of this, you can see even more galaxies that are not visible in the Hubble Ultra Deep Field portion. So we expect to have a lot better resolution, be able to see very fainter objects and see them as they're younger. The second objective is studying the formation and evolution of galaxies. So we're looking here at a typical spiral galaxy that exists today and a typical elliptical galaxy that exists today. But we know that galaxies evolve with time. They've changed, they merge, they collide, they separate, they deal with supermassive black holes, there's dark matter involved. We don't really know the complete history of any of these galaxies. So the James Webb is going to be able to study that. And I'm going to show you a quick video of the galaxies that have that are forming. This is a computer simulation, and I needn't remind you it's highly speeded up. But let's take a look at what we might be seeing. So these are very young proto galaxies. They're very small, very little structure, but as time goes on, they build up and develop more and more complicated structure. Eventually, they actually, this one looks like it's in a process of becoming a spiral galaxy. So that's one of the things we can expect to learn about. Another thing we can learn about, again, this is one of the objectives, studying the birth of stars and protoplanetary systems. Here on the left, we see an image of the famous pillars of creation, the Eagle Nebula. This is an image taken by Hubble in visible light. And you can see enormous amounts of gas and dust in this image that sort of conceal what's really going on inside these dust clouds. These are starbirth regions. These are regions where new stars are being born. When we use infrared light, again, Hubble has a tiny ability to use infrared. This is the same object. Infrared light can see through dust clouds and gas, and it can also see these reddish stars that give off most of their energy in the infrared. We don't even see them in the visible light image. So this will reveal what's really going on inside that nebula. Where one of the things that we know goes on in nebulas are the creation of what we call propylids. That's one of my favorite words now. I wouldn't try to say it 3 times fast though. So these are all images by Hubble of planetary systems in a process of formation. So stars form inside these cocoons of dust and gas, many times larger than our solar system. And eventually they collapse and the star starts undergoing fusion, and the disk, the planets form a disk and start solidifying themselves. But we don't know very much about this. As you can see, none of these images are particularly clear. But I think the James Webb will enable us to get a much better look because of its resolution and because of the fact that it can see in the infrared. I'm going to show you a simulation of what we think planetary evolution and stellar evolution looks like. So
a computer model that represents astronomers' best ideas about the star formation process.
Reddish colors indicate thicker dust. The temperature, less than 400 degrees below 0 Fahrenheit.
Or less than 240 degrees below 0 Celsius.
That pinwheel ahead is a protostar, perhaps 10,000 years old. Protostars arise when a dense knot of dust, less than a light year across, collapses. But the details of the process are not well known.
Elsewhere in the cloud, another protostar is preparing to build planets. As the cloud that created the protostar collapsed, it flattened into a disk. The disk we see here is 600 times the size of Earth's orbit around the Sun.
If placed in our solar system, it would extend far beyond the planets.
In this computer model, the disk continues to accumulate gas and dust from its surroundings for thousands of years. Eventually, the disk fragments, producing dense, bright structures. These may become sites where giant planets form.
Later, during another phase of construction, smaller Earth-sized planets may take shape.
Okay, so let's go to the next slide. So the bottom line is the James Webb will enable us to better understand the process of star formation and planet formation. That's a very hot field in science right now, and we're going to get a lot more information once Webb is observing. Finally, the last objective is to characterize and study other worlds. And by other worlds, I include exoplanets that revolve around stars other than the sun and objects in our own solar system. And Webb will be a powerful instrument to observe both of them. As for exoplanets, here's an image of two of them. This is a brand new star up here. And it's just forming a solar system. You can see one exoplanet here, one here. But I have to point out that this is a rare photograph. Hubble can only do this in a handful of cases that are exceptional. Most of the time we cannot. But the James Webb will be able to, using its resolution and infrared light, it will be able to actually see many more exoplanets using direct imaging. What's even cooler, though, is that we can analyze what's in a planetary atmosphere, what's in an exoplanet atmosphere. So here's the trick. Here's how it's done. Imagine this is the star, and this is the exoplanet. As it orbits around the star, sooner or later, it will cross in front of the star. When it does that, the star's light goes through the planet's atmosphere to reach us. And that light contains information about the planet's atmosphere. Eventually, the planet moves on and disappears behind the disk of the star. And then we're only looking at light from the star. So here's the advantage. When we see the atmosphere, the light going through the atmosphere, plus the light of the star, we can subtract the light of just the star. This may make it a little clearer. So first we have a spectrum that's combined of the star plus the planet. And then we subtract from that the eclipse spectrum of just the star. And that what remains then must presumably be the spectrum of the exoplanet. So, and I needn't remind you, we can't even see these planets. They're so distant, they're so close to their stars and lost in a glare. But this is one way that would definitely work to get us a planetary spectrum. Now, what is that going to buy for us? Let's look at the spectrum of Earth's atmosphere. So we have a very complicated jagged line. Some of these dips represent absorption by water, some by ozone, some by carbon dioxide. All of these chemicals are somewhat related to life on this planet. And it indicates that there is life on Earth. In contrast, look at the spectrum of Venus. It's pretty flat and dull. It has one big drop for carbon dioxide, which composes 95% of its atmosphere. Similarly with Mars, it has a very simple spectrum of its atmosphere. And we have a big dip again for carbon dioxide, because carbon dioxide is the main constituent of the Martian atmosphere. So what we're trying to do is find planets like Earth that can potentially support life, that perhaps do support life. So let's say we find a hypothetical exoplanet like this. The Webb will be able to analyze its atmosphere by the starlight going through it, as we talked about before, and perhaps it will find methane, carbon dioxide, water vapor in its atmosphere. Those are called biosignatures or biomarkers. They are potential indicators of life on that world. We don't know for sure, but it was certainly, if we find a planet like this, it'll get a lot of attention. Similarly, Earth up here, we have ozone, oxygen, methane, CO2, water vapor in its atmosphere. This planet has some of that, so it does look promising. What about planets in our own solar system? Okay, so one of the advantages of the James Webb is where its location is going to be. It's going to be located in what's called L2, the Earth-Sun Libration Point, Lagrangian point, number 2. And it's going to be looking outward. To the back of the telescope, you'll see the sun, the earth, and the moon. The telescope is shielded from all that to reduce sources of infrared light and heat. So the telescope can look outward, but not inward. We will never be able to use the James Webb to look at Venus or Mercury, which are inner planets. But the other planets are fair game. And here's some of the targets that will be investigated within the first year of Webb's operation. Mars, of course, will be able to see enormous amounts of detail. We'll be able to monitor the weather and dust storms as the seasons change. And that could be very useful because right around the time Webb will be still operational towards the end of this decade, we're going to run a Mars sample return mission, an unmanned mission to return samples that the Perseverance rover is now in a process of gathering. These two are called ocean worlds. This is one of Jupiter's moon, Europa, and this is one of Saturn's moons, Enceladus. Underneath this icy crust, we know that there are oceans of liquid water, probably somewhat salty water, and potentially those could be habitable locations for life. What we want to do, though, is monitor these because every now and then there'll be a geyser or an outburst of material breaking out through the icy shell. And the Webb will be able to actually chemically analyze from a distance what is in that material. And it may be very informative for what's inside that world. Here's another object, Saturn's moon Titan. It was studied extensively by Cassini until a few years ago when its mission ended. It could see through the smog layers, the hydrocarbon smog to the surface, but not very well. The James Webb will be able to resolve this image with 4 times the clarity, 4 times the sharpness of this Cassini image, of all the Cassini images. And that's important too, because also towards the end of this decade, there's going to be a mission launched to Titan called Dragonfly, which is actually a quadcopter that's going to land in a certain location, do science, take off and fly to another location, et cetera, et cetera. And the James Webb will be instrumental in monitoring the progress of that rotorcraft. The James Webb will help us understand near-Earth asteroids and comets. Did one of those bring water to us? Is that where Earth's oceans come from? We have Uranus and Neptune, the ice giants. These haven't been visited by a spacecraft since 1986 and 1989, respectively. And when Voyager 2 flew by Uranus, Uranus's south pole was facing us, so we couldn't map the North Pole area of Uranus or its satellites. We will be able to do that with Webb. Neptune has storms and clouds we can monitor, and we can also check out Pluto and its moon Charon and its collection of Kuiper belt objects. We can analyze the surface, detail the surface material, and any atmosphere. So the James Webb is not just an isolated end in itself type of project. It's actually a bridge to the future. There will be more coming. The next major space telescope is called the Nancy Grace Roman Space Telescope. It's targeted to launch at the end of 2025. And it's basically an infrared telescope with a very wide field of view. And beyond that, in the 2030s, NASA is studying, well, currently there are 4 main candidates for the next main telescope. They will have to pick only one of these because these are all flagship missions. They're very expensive. So we are already planning into the 2030s, and the James Webb Space Telescope is what is going to get us there. So let's watch this launch. And this is, again, a simulation of what we think the launch will look like. So here is the Ariane 5 rocket taking off from French Guiana and on a European Space Agency rocket. And it's powering through the lower atmosphere with its solid rocket boosters on either side. Those will be jettisoned as soon as their fuel is used up. Any second now. Thank you. And the main engines will continue to power the James Webb Space Telescope into space. And there it goes. And with that, all I'm going to say is I can't wait. This is going to be a very exciting time around December, if that launch date holds, or whenever it does come about. So finally, I'd like to remind you of some of the things Irene talked about. On Friday, October 15th, we'll have an official NASA-sponsored Webb Telescope community event. The James Webb Space Telescope, we can see the beginning. And we will talk about, that's going to be at 7 o'clock, and it's an in-person event at the Christa McAuliffe Center at Framingham State University, but it will also be available via live stream. And as a guest speaker, we'll have Dr. Catherine Flanagan, an astronomer emerita at the Space Telescope Science Institute. And that institute, by the way, is the facility that will run James Webb, runs Hubble, will run the Roman Space Telescope. That's the center of action. So I'm looking forward to hearing from Dr. Flanagan. And finally, on Saturday, December 18th, we're going to have a launch party. If that's when the launch occurs, and we can find a time to do it, we will absolutely have that launch party. So with that, I'm going to end, and I'm going to give it back to Irene, and maybe there will be questions and answers. So hopefully answers. So I'm going to stop sharing now.
Thank you, John. I'm sure there will be a lot of answers as well. So as always, I want to encourage everyone to post your questions in the Q&A. And yes, over these three months that we've been talking about James Webb, I know that my excitement has been growing. Now, I mean, my mind is really focused on December 18th. We hope that the date is confirmed. I want to inform everyone, yes, it is a Saturday, in case you were checking the calendar. And as far as we can tell right now, the launch is going to be probably around 7:30 a.m. But as far as we are concerned at the McAuliffe Center, we are going to plan something. So stay tuned. Of course, as the date is further confirmed or the time it comes out, but we'll definitely share that information with you all. And it's going to be a strange time to do this kind of event, but it's going to be really, really exciting. And as John mentioned to us in a previous presentation, it will take 6 months of commissioning, what means that over those 6 months, the telescope will reach its position at L2, and also the various instruments will be checked and so on. So only 6 months later, the telescope will take its first, what is called first light. It will take probably the first image, first spectrum. But over the period of 6 months, we will provide monthly updates on what's happening with James Webb. So it's going to be a mission that we're going to talk about for years and years to come. just like we've been doing with Hubble. It's been more than 2 decades with Hubble, but we keep talking about the great science it allows us to do. So I'm waiting to see what questions that may come from our audience. I actually have a question for you, John. I think I have an idea of what is your most, the topic that you're most excited about, meaning in terms of what Webb is going to be revealing to us. But do you want to tell us what is it you're the most excited about?
Sure. Well, personally, because as Renee mentioned, I'm a NASA Solar System ambassador, so I'm very interested in our solar system. I'm very interested in planets, the outer planets in particular, because that's where a frontier is of space exploration. And those are worlds that have been reached by human machines, and maybe someday people will go there. But in the meantime, we learn so much about Earth by studying other planets. And I think this is a time when it's desperately important for us to figure out how planets work.
Yeah, I had that suspicion that was the topic you were the most excited about. But it's great. And again, the fact that there was a main science objective for the design, even to justify the design of such a powerful telescope. But once we have that machine, there are so many other things that we can do. So yes, I cannot wait for the moment we will see a picture of the first galaxies ever formed. I mean, just to think about that, and maybe that's going to be harder to do. We know that, but maybe pictures of the first stars. It gives me goosebumps thinking about that. So that's really exciting. But on the other end, you have such a beautiful instrument. What else can we do that is going to be super exciting? And learn more about our solar system is certainly one of those things. Figuring out if there's other planets that are out there in the galaxy might provide some evidence that there is potentially life on them. That's going to be super exciting. Another quick question, because I know we talked a little bit about, but it's a very complex mission. And there is something that, I know that many scientists and engineers are worried about if some parts, we know that this telescope, the mirror will open up, unfurl, right? The sunshade will unfurl as well. We talk about origami all the time. So I know that you learn a little bit something about what if some of these technical aspects don't function well, if the mirror doesn't open up completely, or if
I actually read something from one of the scientists, Heidi Hamel, that is involved deeply in the project, and she said that okay, if the worst happens and the sunshade doesn't completely open, they'll still be able to do some science observations. Maybe not as many because the telescope may be affected negatively. If the mirror does not unfold completely, the 3 sections, they'll still be able to do science. But if the secondary mirror that captures the light from the primary mirror, if that doesn't lock into place properly, then unfortunately, the mission will be a failure. We won't be able to do any science at that point. But look, let's think positive. That's not going to happen.
Yeah, I mean, that's really a worst case scenario. And of course, the engineers have been planning the mission. They need to consider all possibilities. But in one way or another, I'm sure there will be great science that comes out of this telescope. We learned yesterday, we were together on a teleconference that was also talking about James Webb. What a lot of scientists right now are excited about is all those new things we will learn that we don't even know we will, not part of the official science objectives like we introduced today, but there is going to be a lot of new discoveries that are going to happen just because we point the telescope in one direction and another. A little bit like you showed to us with the picture of a deep field with Hubble. I mean, people knew that we were going to see something, but exactly what and how many galaxies? I mean, that was revealing. So there's going to be a lot of new discoveries that we don't even know what they are potentially going to be, right? That's
how science works. You set out to get answers to some questions, and maybe you get them, but that raises a whole host of other questions that you need to pursue. So that's a good thing.
And that's why I appreciated also the fact that you showed to us that James Webb telescope is not going to be the end, but it's just going to be the beginning. It's almost like we are entering in a new chapter for astronomy in general and space science. Like, again, Hubble opened a new chapter in our research. James Webb will open a new one for those follow-up or contemporary, actually, other telescopes will complement in part the research that we'll be able to do with Webb. So that's also very, very special. All right. Well, I think, I don't know, either I don't see any new questions in our Q&A. We'll just give you one more minute to think about that in case you wanted to ask some more questions, but I'll take the time to remind everyone that, again, we will have a very special event on October 15th. That's going to be our official NASA community event to celebrate James Webb with Dr. Catherine Flanagan as a keynote speaker. We will have actually a new, about 10 minutes planetary multimedia program being developed in-house that we will show for the first time then, followed by the presentation. And again, we will make sure that, we will be an in-person program, but also live stream. So we want to reach out to as many people as possible with this special event. So I'll encourage you all not just to participate, but share information with your family and friends. Again, we will be available via live stream across all states, so and beyond, of course, if that's the case. And then be ready for a launch party. I think we will be drinking champagne at 7:30 in the morning. That's going to be interesting. Maybe not champagne, maybe it will just be something not alcoholic. At that time in the morning, it's not very good, but we'll definitely celebrate in style.
Yeah, sometimes when a big mission like this gets launched, the people involved or even the public goes to Florida, to Cape Canaveral to watch the launch. Unfortunately, this time that won't be possible because, as we said, the launch is from French Guiana on the coast of South America, and it's not a particularly tourist-friendly area to go to. And it's very inconvenient. So we'll have to watch the launch on media.
And we will. And on that note, again, we just invite you all to join us on October 15th. I want to thank John again, not just for tonight, but for giving us 3 really interesting and engaging presentations. I know that I feel I know much more about Webb now, and I hope our audiences feel the same. But again, join us on October 15th and then on December 18th for a big launch party. Thank you, everyone, and good night.
Good night.